it's been taught about the 9 different planets in the solar system. However, recent findings have called into question the definition of a planet. Hello and welcome to CU Science Update. I'm your host, Jenna Browder. In 2006, the International Astronomical Union declared Pluto the 9th and most distant planet in our solar system as a dwarf planet. So what gives? Since its discovery in 1930, Pluto has always been a planet. Suddenly, we're back to 8 planets and now a new class of objects called dwarf planets, of which 3 are known to circle the Sun. The International Astronomical Union made its decision after agreeing that planets and dwarf planets fall into 2 distinct classes of objects. For an object to be a planet, there are 3 criteria that must be met. First, a planet is an object that is in orbit around a star. Simple enough. And second, this object has to have sufficient gravity to make it nearly spherical. Of course, Pluto fits within these 2 guidelines. However, it falls short in the third, which says that a planet must become gravitationally dominant in its orbit. In other words, for Pluto to be a planet, it must have cleared its orbital neighborhood from objects of comparable size. And sadly, Pluto shares its orbital neighborhood with objects from the Kuiper Belt, a region around the outermost edges of our solar system that contains over 1,000 small objects composed of frozen volatiles such as methane, ammonia, and water. Pluto is known as one of the largest members of the Kuiper Belt. It's recognized as a new class of trans-Neptunian objects called Plutoids, which include a dwarf planet called Eris. And there's yet a 3rd dwarf planet in our solar system called Ceres, which is located in the asteroid belt. But not everyone agrees with the reclassification of Pluto as a dwarf planet. We'll be meeting with one CU professor who has a few words to share about Pluto's status. But first, let's take a look at how Pluto came to be the 9th planet in our solar system. At the start of the 20th century, American astronomer Percival Lowell began the search for a planet that could explain irregularities found in Neptune's orbit. Lowell spent 13 years searching for what he called Planet X, but he died in 1916 without ever finding it. However, the search continued at the Lowell Observatory under the keen eyes of astronomer Clyde Tombaugh. He examined hundreds of photographic plates, looking for a tiny speck of light that could change locations from one plate to the next. In 1930, Tombaugh found what he was looking for. Pluto became the official 9th planet of the solar system. Eventually, 11-year-old Venetia Burney of Oxford, England, came up with the name. Pluto, Roman god of the underworld, was a fitting name for a planet that was seemingly dark and cold.
Pluto is this little object right here.
Oh. I don't know whether you folks at home can see that. It's about the smallest spot on there. In fact, the whole thing looked like somebody sprayed milk through a screen door. Pluto is there. Now, out of all of this mess, how did you find this one little thing?
This photograph was made on the 29th of January, 1930. On another photograph made 6 nights earlier, it was up here.
This little spot was up here?
Yes.
For 80 years, Pluto the planet has captured the hearts and minds of many, from school kids to scientists. In the coming decades, we would discover that Pluto has a moon, Charon. And in the 1970s and 80s, NASA's Voyager mission reached the outermost portions of the solar system and sent back stunning images. But they only got as far as Neptune. All we've ever seen of Pluto is a faint speck. No one knows exactly what it looks like up close, at least not yet. Not until NASA's New Horizons probe reaches Pluto in 2015, and on board the probe is a piece of CU ingenuity. The CU Boulder Student Dust Counter is the first student-built instrument ever selected by NASA to fly on a planetary mission. We visited with students and scientists on campus about the research being done here at CU. CU Science Update Sara Hanning reports.
Here at the Laboratory for Atmospheric and Space Physics, we are looking into the Mission Operations Center to see how CU is furthering space exploration.
CU is a unique campus in that it has several NASA-operated missions run from the Laboratory for Atmospheric and Space Physics. There is the Kepler mission in Boulder that is searching for new habitable planets.
Right now we've got a really exciting mission called Kepler that we operate from LASP. It's a $700 million NASA mission, and we're using that to find planets around other stars, particularly near the Orion constellation. Because we're looking for other planets, there's never been a mission like this before. and we're studying 150,000 stars in the meantime. So that alone will teach us give us a lot of new information that we can relate back to our sun, which also happens to be a star.
It takes careful preparation to launch new satellites into space.
Satellites are very well tested on the ground, but there are a lot of things you cannot well test. And once you get up into space, that's when you actually have to figure out exactly how they behave and make changes according to how they actually behave.
There's, of course, the New Horizons mission, destined for Pluto.
And it'll be a really exciting mission because it's got a lot of cool instruments on board. LASP actually has a dust collector on the spacecraft. And we're hoping to find out more about Pluto and the potential planets or other objects beyond there.
For CU Science Update, I'm Sara Handing.
Thanks, Sarah. And now joining us in our studio is CU Professor of Astrophysics, Fran Bagenal.
Hi, I'm Eric Duggan, and I'm here with CU Professor Fran Bagenal, and we're going to talk about Pluto. So the big question is Pluto a planet?
Well, that's a very simple question that you would expect a yes-no answer, but the reality is much more complicated. We have to go back in history a bit here, because things used to start off, we had stars in the sky, we saw some stars that moved, they were the wanderers, they became the planets, so we had two types of objects. Then they discovered comets, these things that would whiz through the sky, change over a period of about a year, and they would have this big stuff spewing out. So there was another kind. And then we discovered that there were these other objects that were smaller objects, asteroids we now call them. And then there were these other things that were orbiting planets, the satellites. So Galileo discovering the Galilean moons 400 years ago this year. And so things began to change, and each time we discovered a new kind of object, we had to sit back and say, okay, what's going on here? What does this mean? What's happening? So the past decade or so, we've been discovering that there are now about 1,000 or more objects that are orbiting out in the orbit of Pluto. And so this means that we have to think, okay, so what are we doing here? Do we call Pluto a planet, which is what it was when there was only one of them? Or do we have to change our definition of what we call a planet? And so, we've now called Pluto a dwarf planet because it's part of the Kuiper Belt, the 1,000 objects out there past the orbit of Neptune. So it's still a planetary object. But it's a small planetary object, and it's got a bunch of cousins. So we call it dwarf planets, or Kuiper Belt objects.
What's the big difference between a dwarf planet and a regular planet? What's the distinction? Size,
and the fact that it is surrounded with a bunch of other things that are similar. So it's much more akin to one of the asteroids in the asteroid belt. Size is important geologically because if it's more than, say, about 700 to 800 kilometers across, about the size of the state of Colorado, or let's go for Texas, a big state. About that size, it has enough mass to pull it together to make it round. Whereas if it's much smaller than that, it sort of looks like a potato. So that has a big difference in terms of geology and surface behavior. So if you want to use roundness to be part of the definition, then you would probably have to also include some asteroids, because Ceres and Vesta are pretty much round. They're big enough. The only two asteroids that are. And several other objects out past Pluto, or with Pluto, are big round objects too. So, it means then instead of having 9 planets, we probably have 15, 20, but there probably aren't hundreds of things that are round in the outer solar system.
And when they voted to make Pluto a dwarf planet, there was a lot of debate between different fields in science about what constitutes a planet. You had the geologists differing from the astronomers. So in your opinion, in your field, what is the distinguishing characteristic?
Well, there was a little bit of, it's a bit like dogs pissing on lampposts, to be quite blunt with you about this. Because those of us who work on Pluto feel this is our planet, it's mine, and who are you people to pontificate about whether it's a planet or not? And, yeah, we kind of resented other people coming in and saying what was going on. But that's silly because, you know, science is a public endeavor that everybody's involved. And just because we're sending a mission to Pluto, the New Horizons mission, doesn't mean that we have an entitlement to say, you know, this versus the other. So, yeah, there was, but that's just a sort of mild cultural amusement. I think we've gotten over it.
Tell us more about this New Horizons mission that's going to Pluto. What are we hoping to find out?
We have never sent a spacecraft to go look at any of the Kuiper Belt objects, these 1,000 or so objects that are out beyond the orbit of Neptune. And Pluto is the obvious one to go look at. It's the first one discovered, obviously. It's one of the larger ones. There is one other that's discovered to be bigger. There are others of similar size. But Pluto's the one we picked to go and see, mainly because we found it first. And we've got a spacecraft that is on its way. It was launched in 2005. It went past Jupiter, got a kick to get it there a little faster in January of 2006. And it'll get there on Bastille Day, so 14th of July 2015. So we've still got another 5 years or so to go. We're getting there slowly. But we'll have pictures that are better than Hubble pictures, because Hubble pictures are sort of a little fuzzy dot right now. We'll get better pictures about 3 months before we arrive. And then we'll start making measurements of the atmosphere and the surface. We'll take pictures. Now, we only have 2 hours when we really fly past close. So it'll be click, 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 like that as we go by, take lots of pictures, and then we'll spend months sending the data back slowly, because it's a long way to send the data, so it'll have to come back slowly.
So what happens to the rocket? Does it just keep going?
The spacecraft keeps going, right? So it doesn't have much power, so we can't change it much, its direction. Carried a little bit of fuel to change its orientation. We're looking right now for some more objects to fly by, similar Kuiper Belt objects. We hope within a couple of years or so to decide which ones we're going to go by. But, you know, we can wait till we get there before we decide where to go next. We'll make a little correction, maybe a couple of degrees, and maybe fly past another one. The chances are good we'll find another one to fly by.
Is this the farthest we've ever sent a mission?
No. You know, just last week I was looking with a friend at some data that came back from 93 times the distance between the Earth and the Sun. So that's nearly 100 times further away the Earth is from the Sun. And that's the Voyager spacecraft. So the two Voyagers that went past Jupiter, Saturn, Uranus, Neptune are off in the outermost part of the solar system. They are exploring that boundary between where the solar wind coming from the sun, our sun interacts with the material from other stars. So that's the sort of the outer edges of the sphere of influence of the sun, the heliosphere.
So when you get your data from Pluto and passing all these planets, does that help to tell us about how the solar system was formed and about Earth itself?
The key thing is to try and work out what is the layout of the solar system. That's the first sort of thing you need to do. So we sort of need to know where all these objects are and how they orbit and how they behave. Next thing is to look at their surfaces and try and understand what they're made of, how they got to be that way, what are the geological processes on the surface. We have no idea what the surface of Pluto is going to look like. We know it has ice on the surface. We know it has dark patches and light patches. But that's it. That's all we know.
So, and everything up until now, it's just been telescope images, no actual close-up images?
That's right. So we can use Hubble Space Telescope, which has produced the best pictures. And then we use other ground-based telescopes to look at the composition. We can work out the composition using spectroscopic techniques, that looking at the wavelengths, different wavelengths of light to try and work out what the surface is like.
So to you, since you've been studying Pluto all your life, what does that planet mean to you?
It means, really what it is that in my lifetime, we have gone from this is just a speck in the outermost, its only speck in the outermost part of the solar system, to being one of a whole class of objects that have very interesting different orbits, that we now know that they were probably put there by the migration of Uranus and Neptune, that the whole formation of the solar system was a complicated dance of different objects whizzing about, being kicked by the gravity of Jupiter and the giant planets. Much more complicated, interesting, rich story that we're now finding is the story of the solar system.
For Pluto, could we ever go there, do you think? Would we ever go that far out into the solar system sometime, hundreds of years from now?
You mean take humans?
Take humans.
Well, the problem is humans are very difficult things to deal with. I don't think it's likely. It's way cold out there, you know, minus 300 degrees. It's a long way to carry these big, very massive objects, humans. You have to carry food, you have to deal with water and air, and I don't think we're going to go out to Pluto. In fact, I don't actually think in our lifetime we're even going to get to Mars. But who knows? Maybe we'll find a new way. We'll warp drive.
Thanks, Eric and Professor Bagenal. Today, we explored the outer depths of the solar system, but it is still widely debated whether or not Pluto is in fact a planet. We'll have to wait until the New Horizons spacecraft reaches the Kuiper Belt to better study the dark and icy composition of Pluto. That's all the time we have for this edition of CU Science Update. Thank you for joining us, and see you again next time.